Assalamualaikum and hi everyone. Let's continue with the third part on topic 6, which is on access modifier. In this part, we will learn about the modifiers such as public, default, protected, and private. We will then learn how we can access and modify private data using accessor and mutator methods, which also known as getters and setters. The visibility modifiers dictate the accessibility of class components by the clients. This can be for the methods and also the data members or data fields. Anything that is considered as internal details should be declared as private. If a class component, the data member or method, is declared private, client classes cannot access it. This is information hiding. If a class component is declared public, all classes can access it. For example, say that we have a bank class. We do not want everybody to have access to the bank account and able to withdraw money from any account. So, we need the detail about the account to be private. We might want everybody to know about the bank and the location of the bank. So those data should be public, which means anybody can know about those. Visibility modifiers. The members of class are classified into 3 categories. The first one is public. If a member of a class is public, it can be accessed from outside the class. For private, if a member of a class is private, it cannot be accessed from outside the class. Methods and data fields are accessible only within its own class. For protected, if a member of a superclass needs to be accessed in subclass, meaning that it is within the same package, and still prevent its direct access from outside the class, it must be declared as protected. When we do not write anything, that means that it is the default type. This is for the method and data members or fields. The keyword default is not written when assigning default accessibility. This table here summarizes the accessibility modifiers in terms of the accessibility with the class, package, and outside of the same package. You can think of package as being in different folders. Private is the most restrictive modifier, followed by default, protected, and public is the least restrictive. When it is public, it can be accessed outside of the class from different packages as well. In private, only within the class itself. In default, as what we have been using, it can be accessed within the same class and also classes within the same package. We will see an example of it. Protected cannot be accessed by class in different package. This slide shows a simple example of public and private modifiers. See how the client can access the public data member and method. We create an object of class service called object. As what we have learned previously, to call methods or variables or data field, we need to use the dot operator. So, to call the data field member1, we can write object.member1 and assign to it the value 10. This is valid because member1 modifier is public. On the next line, we cannot do object.member2 equal to 20. This is because in service class, we say that member2 is private. When it is private, it cannot be accessed by classes outside of the service class. It can, however, be accessed within the service class. We will look at that example in the next few slides. Similar with data fields, methods work the same with the modifiers. Do1 method is public, so we can invoke it as usual by writing object.do1. However, as do2 method is private, we cannot access it by writing object.do2. In fact, there is no way that we can access do2 method from other classes. So, it is important that when we use private, make sure that in your code, perhaps you might want to add certain class to access the value of it without giving them the ability to change the value. This is the concept of having accessor, or also called as getter methods, and mutator or setter methods. Let's look at more example on private modifier. Say that we have these two classes called Modifier and Modifier Test. In Modifier class, we have a data member, private final double pi equal to 3.14. Can this pi be accessed by the main method in Modifier Test class? For example, by doing m.pi as highlighted here. Does it show the value 3.14? When we try to compile the code, it will give us an error because pi is private, meaning that it cannot be accessed by other classes. It can, however, be accessed by its own class. In the modifier class, we have a method called modifier method that is public. In the modifier method, we create an object of the class itself by writing modifier A equal to new modifier. This is actually unnecessary, but we can do it. We then have a print line to display in modifier class, and then a print line that calls a.pi. We now try to access the private variable pi. If we compile the modifier class, this is valid. It shows that within the same class, it can access its private data. In the modifier test class, we invoke the modifier method by writing m.modifier method. So, modifier test can indirectly access the value of private pi through the public modifier method. The same goes for private method. Say that we modified the code in modifier class. We change the modifier method to private. So, within the modifier test class, if we do m.modifier method, it will give us an error because modifier method has private access, so we cannot invoke it outside of the class. However, within the same class, it does not matter that the method or data is private. In modifier class, we have another method called public method that is public. It can invoke the private modifier method. So, in the modifier test class, we can access private modifier method and also private pi through public method. Other accessibility modifiers, public, default, and private, can be seen from this example. Here we have two classes called C1 and C2. Both are within the same package or folder, so it has to be defined as the first line in the source code as shown here, where it wrote package P1, semicolon. This is clearer if we look at the project within NetBeans, as it can show the hierarchy of the files. It shows that in P1 package, it has C1 and C2 classes. In class C1, we have public int x, int y, where this means int y is the default type, as we do not write anything in front of it. And we also have private int z. For the methods, we have public void m1, void m2, which means m2 is the default type, and private void m3. All these methods do not do anything. That's why we have the opening and closing braces straight away. In C2 class, it creates an object of C1 class called O. To access the data and methods, the dot operator is used. When we do O.x, that is valid because public can access by any classes. O.y is also valid because even though y is default, it is within the same package, P1, so it can be accessed. O.z, however, cannot be accessed because z is private. When it is private, it can only be accessed within its own class, meaning that only C1 class can access z. The same goes for the methods. O.m1 is valid because m1 is public. O.m2 is also valid because m2 is default and class C2 is in the same package as class C1. O.m3 is invalid because m3 method is private. So in this example, it proves that within the same package, we can access data and methods that is public and also the default type. You can try and compile both classes to see if it gives you any error. It will not display anything on the screen because we do not have the main method and the methods here are not doing anything. Say that now we have another class called C3 and it is within another package or folder called P2. In C3 class, to ensure that it can find where C1 class is, we have to write import p1.c1. This will import C1 class. In previous topics, we have learned how to use import. We have used it when we want to use the scanner class, where we wrote import java.util.scanner, where java.util is the package and scanner is the class. This is exactly the same as that, where p1 is the package and c1 is the class. In the previous example, we have class c2 that is within the p1 package. If we want to create an object of class C2, we need to import C2 class. So what we can do is we can write another import statement in class C3 to import C2 class. We can write import p1.c2. Or we can say that we want to import all classes within the p1 package by writing import p1.*. This will import class C1 and class C2. Going back to the code of C1 and C3 class, here within C3, we want to access the data and methods from C1 class, so we create an object of C1. Within the different package, C3 cannot access data and methods that are private and default. This proves what we know about the accessibility of the different modifiers, where default can only be accessed within the same package. Private can only be accessed by the class itself, and public can be accessed by any classes in any packages. What we have seen so far are for data fields or members and methods. The same goes for the class modifier. Say that we have class C1 that is default, and public class C2 and public class C3. C2 can create an object of C1 because they are in the same package called P1. C3 cannot access C1 because they are in different package, but C3 can access C2. This is because C2 is public, while C1 is default. To recap about access modifier, the private modifier restricts access to within a class. The default modifier restricts access to within a package, and the public modifier enables unrestricted access. Accessor and mutator methods. By default, the class variable or method can be accessed by any class in the same package. When instance data is private, a class usually provides services to access and modify data values. The get and set methods are used to read and modify private properties. An accessor method returns the current value of a variable. Accessor methods is also called as getters, as it is used to get the private values. A mutator method changes the value of a variable. It is also called as setters, as it can set the private values. The names of accessor and mutator methods take the form of getX and setX respectively, where X is the name of the value. Mutator restrictions. The use of mutators or setters give the class designer the ability to restrict a client's options to modify an object's state. A mutator is often designed so that the values of variables can be set only within particular limits. Let's look at this example. We have two classes called rectangle test and rectangle. Rectangle test has a main method and it creates an object of rectangle and tries to access the data members from rectangle class of type private. Within the rectangle test class, when it do r.length or r.width, it will get an error because length and width are private. They can be accessed through the accessor methods. From the previous slides, we know that the name of accessor methods take the form of getX. Here, X refers to the width and length. Accessor methods always have the type that is the same as the private that we want to access. Within the method, it will return the private value. By doing so, we can access the private value from another class. Two accessor methods that we have are public int getLength and public int getWidth. Each of those has a return statement that returns the values accordingly. So within the rectangle test class, it can get the value 5 and 7 through these accessors. It can call r.getLength and r.getWidth method. Mutator method is when we want to set the value to something else. We cannot do r.length equal to 4 or r.width equal to 3 because they are private. So instead, we can use the mutator methods. The syntax for it is public void setX parameter list, and X is the data that we want to set. The mutator methods are public void setLength int L, where int L is the new value of length that the user wants to have. As what we have learned about method, the parameter can be called anything. We can use int length instead of int L. Within the setLength method, we must write length equal to L. On this line, what happened is we reassign the value L to the private variable length. Remember that even though length is private, it can be accessed and reassigned to any value within the same class. We will do the same for setWidth method. In the rectangle test class, we can invoke those methods as usual. We can write r.setLength 4, for example, and r.setWidth 3. Those can be any values. If we run this code, we will get the output rectangle values length 7, width 5, which are the initial values. And after we use the mutator methods, we have rectangle values length 4, width 3. In short, accessor and mutator are basically normal methods that we name as setX and getX. We can use normal methods if we want. It will work similarly. But we normally name those methods as setX and getX so that we know what those methods are, which is to access the private data. In our code, we do not need to have both accessor and mutator. It depends on what we need in our program. If say that our program does not want the user to change the value of it, then our program can have only accessor. Another interesting thing to know is within the setters header, as I mentioned before, we can use int length and int width instead of int L and int W. However, when we are using the same identifier name as the data in the class, the compiler will get confused. It will assume we are reassigning the new value to itself, which is not what we want to do. So we have to use the keyword this. We have to write it as this.length equal to length and also this.width equal to width, where this.length will refer to the data within the class and length after the equal sign will refer to the parameter value. The same goes for this.width and width. Going back to the access modifier, why we should use private? Data members are the implementation details of the class, so they should be invisible to the user. Declare them as private. If a data member is declared public, then the user can make changes directly that can affect the internal operation adversely. Hide the component that needs to be hidden to maintain the integrity of the class. Although class constants should be declared public when direct access to them is desired, please note that once a constant is declared public, its name cannot be changed without affecting the user's code that made a direct access to it. So it is important to derive a good name that you don't have to come back and change it. For example, if we have public final double pi equal to 3.14, the user can access it by object.pi. If we change pi to my_pi value, then the user's code will have an error because the constant pi does not exist. How to decide the visibility modifiers? We should declare the class and instance methods private if they are used only by other methods in the same class. Declare the class constants public if you want to make their values directly readable by the client programs, because when they are public, any classes can access it. If the class constants are used for internal purposes only, then declare them as private. This figure here shows a Unified Modeling Language UML diagram. We do not cover about UML, but a quick overview of it. In UML, we have three parts of it. The top one is the class name, the second part is the data fields or attributes or variables, and the last part is the methods that the class have. So, to represent private or public, we use the plus symbol for public and minus symbols to mean private. To summarize, we have looked at examples of using modifier public, private, and default. We have also looked at how we can access and modify private data using accessor or getter and mutator or setter methods.